Assalamualaikum warahmatullahi wabarakatuh. Hello guys, we are from group 2. Today we're gonna discuss about metal. First, I'm gonna introduce myself and my other friends. I'm Auleda Mayanti, and there are also Febriansa, Andia Diat Muhammad, Nika Dekwinasi, and Fiorenza Agusta Mandai. Next. So first, we're gonna know about metal. So what is metal? Metal is the material, an element, compound, or alloy that is typically hard, opaque, shiny, and has good electrical and thermal conductivity. Next. Metal classification. Metal can be divided into two main groups, ferrous metal and non-ferrous metals. Next. A ferrous metal is any metal that is primarily composed of iron and has magnetic properties. A ferrous metal is known for its hardness, durability, and tensile strength. Ferrous metals are known and used for their strength. The properties that they possess make them perfect to be used in both the industrial and architectural sector for projects like skyscrapers, bridges, railroad projects, and vehicles. Due to their magnetic properties, ferrous metals are also widely used in various appliances and engines. Ferrous metals are widely used in almost all industries, such as in the manufacturing of shipping containers, industrial piping, automobiles, railroad tracks, ships, and many commercial and domestic tools. Next. Ferrous metal can be divided into three parts. First is raw iron. Raw iron is composed primarily of elemental iron with small amount 1 to 2% of added slag. The byproduct of iron are smelting, generally consisting of a mixture of silicon, sulfur, phosphorus, and aluminum oxides. Raw iron is made by repeatedly heating the material and working it with tools to deform it. Raw iron is highly malleable, allowing it to be heated and reheated and worked into various shapes. Raw iron grows stronger the more it's worked, and is characterized by its fibrous appearance. Raw iron contains less carbon than making it softer and more ductile. It is also highly resistant to fatigue. If large amount of pressure are applied, it will undergo a large amount of deformation before failing. Next, the second is cast iron. Cast iron is produced by smelting iron-carbon alloys that have a carbon content greater than 2%. After smelting, the metal is poured into a mold. The primary difference in production between raw iron and cast iron is that cast iron is not worked with hammers and tools. They are also different in composition. Cast iron contains 2 to 4% carbon and other alloys, and 1 to 3% of silicon, which improves the casting performance of the molten metal. Small amounts of manganese and some impurities like sulfur and phosphorus may also be present. Difference between raw iron and cast iron can also be found in the details of chemical structure and physical properties. Although both steel and cast iron contain traces of carbon and appear similar, there are significant differences between the two metals. Steel contains less than 2% carbon, which enable the final product to solidify in a single microcrystalline structure. The higher carbon content of cast iron means that it solidifies as a heterogeneous alloy and therefore has more than one microcrystalline structure present in the material. Next. And the last is steel. We're gonna talk mainly about carbon steel. Carbon steel is a special type of steel that, as the name suggests, has a higher concentration of carbon than other types of steel. Most types of steel have relatively low carbon content of about 0.05% to 0.3%. In comparison, carbon steel has a carbon content of up to 2.5%. It may sound insignificant benefits that aren't found elsewhere. And then carbon steel divided into 4 parts. First is low carbon steel. Low carbon steel, also called mild steels, contain just 0.05 to 0.25% carbon, low cost and malleable. These steels are widely used for items such as nuts, bolts, and forgings. The surface hardness of this steel can be increased by carburizing. Second is medium carbon steel. Medium carbon steel contains 0.25 to 0.6% of carbon. This higher carbon content provides an increase in strength and hardness over low carbon steels. However, these steels have reduced ductility compared to low carbon steels. Increases level of carbon and manganese in medium carbon steel means that they can be tempered and quenched. These steels are widely used for making components for the automotive industry, such as gear, axles, and shaft, but also suitable for use on a railway application. The third is high carbon steel. High carbon steel contains 0.6 to 1% carbon and are the strongest of the non-alloy steel. These strengths make them ideal for application requiring resistance to mechanical wear, while they are also good at maintaining their shape. On the negative side, these steels are inferior to lower carbon steel when it comes to moldability, ductility, and impact toughness. High carbon steel is used for springs, blades, rail steels, wire rope, resistant plates, tools, and more. And the last but not very least is very high carbon steel, approximately 1.25 to 2% carbon content. Steel that can be tempered to great hardness, used for special purposes like non-industrial purposes, knives, axles, and purchases. Most steels with more than 2.5% carbon content are made using powder metallurgy. That's enough from me. Next is from my friends.
Okay, thank you Aulia for the presentation. Okay, so next we're gonna discuss about non-ferrous metal. Non-ferrous metal are alloy or metal that do not contain any appreciable amount of iron. Next. Non-ferrous metal tend to be more expensive than ferrous metal, but are used for their desirable properties, including lightweight like aluminum, high conductivity like copper, non-magnetic properties or resistance to corrosion like zinc. The difference about ferrous and non-ferrous metal is that ferrous metal contain iron. Ferrous metals such as cast iron or carbon steel have a high carbon content, which generally makes them vulnerable to rust and when exposed to moisture. However, this is not the case for worked iron, which resists rust due to its purified and stainless steel, which is protected by corrosion by the presence of their chrome. Next. Okay, for the example is one, aluminum. Aluminum is chemical element with the symbol Al and atomic number 13. Aluminum has the density lower than those of other common metals at approximately 1/3 of steel. It has a great affinity toward oxygen and forms a protective layer of oxide on the surface when exposed to air. Aluminum is a good conductor. Light and strong, it's also a good conductor of heat. It can be folded into sheet, drawn into wire, and extruded into bars of various cross-section, corrosion resistant. Aluminum used in many things. Most of it is used in high voltage cable. Also widely used in window frame and airframe. Found in home as pot, soft drinks bottle, milk bottle, dan okay. Aluminum is also used to coat car headlight and compact disc. Next is copper. Copper is chemical element with the symbol Cu and atomic number 29. It is a soft, malleable, and ductile metal with very high thermal and electrical conductivity. A freshly exposed surface of pure copper has a pinkish orange color, just like you can see in the picture. Copper is used as conductor of heat and electricity, as a build material and as a constituent of various metal alloys, such as sterling silver used in jewelry, cup chronicle used to make marine hardware and coins, and constant use in strain gauge and thermocouples for temperature measurement. Next. Next is nickel. Nickel is chemical element with the symbol Ni and atomic number 28. It is a silvery white lustrous metal with a slight golden tingle. Nickel belongs to transition metal and it's hard and ductile. Nickel is a metal that is light, malleable, slightly ferromagnetic, and rather good conductor of heat and electricity. Nickel is also resistant to oxidation. It is easily attracted by magnet, soluble in nitric acid, insoluble in water and ammonia, and slightly soluble in chloruric and sulfur acid. Next. And for the last is zinc. Zinc is chemical element with the symbol Zn and atomic number 13. Zinc is slightly brittle metal at room temperature and has a silvery grayish appearance when oxidation is removed. Most zinc is used to galvanize other metals, such as iron, to prevent rusting. Galvanized steel is used for car body, street lampposts, safety barriers, and suspension bridge. Large quantities of zinc are used to produce die casting, which are important in automobile and electrical hardware industry. Zinc is also used in alloys such as brass, nickel, silver, and aluminum solder. Zinc oxide is widely used in manufacture of very many products such as paint, rubber, cosmetic, pharmaceutical, plastic, ink, soap, battery, textile, and electrical equipment. Zinc sulfate is used in making luminous paints, such like fluorescent light and X-ray screen.
Next, the property of metal are mechanical, physical, and chemical. Next. The next material I will explain is mechanical. What is mechanical? Mechanical property is a material with a range of plate external force such as stresses, law, water condition, and time. As for the mechanical part, namely hardness. Hardness is the ability of a metal to reach penetrable or material. Though the property of metal relates to hardness. Hardness testing with depending on the proper adaptation. In engineering involving metal, hardness is expressed on the ability to withstand indication, penetration, or by other definition is the risk of metal to plastic deformation. Next. Strength. Metal is resistant of material to deformation in the low area as well as the surface of the material. As for the type of strength is tensile strength, compressive strength, shear strength, torsional strength. Next. Toughness. The ability of material that can burst energy at the time of field agency to include picture toughness. One definition of material toughness is the amount of energy per unit volume that a material can absorb before structure. The mixture of thickness is different for the measure of thickness is different from the ask for picture thickness. With this burst, log brick come of material will flow. Next. Ductility. The ductility of metal is the property which allows it to be strengthened of otherwise. Changer is shipped with breaking and read the changer shift after the long is be removed. Material that general described as ductile include glue and copper. Malleability, a minor mechanical property, is characterized by material ability to deform plastic with or under competitive strength. Next. Elasticity. Elasticity is the ability of metal to return to its organic size, shape, and dimension after being deformed, struck off, fall off, out of shape. Next. Fatigue. Law explains often behavior of metal under changer mechanical law with time is cloud of fatigue. Creep. The creep is a slow and progressive deformation of a material with time at a constant force.
So I will explain about the physical properties of metals. So in this section, I will explain 5 points to explain the physical properties of metals. Next. The first about the density of metal, which is based on the density of metals into namely like metal with a density of 0,860 sampai dengan 5,0 gram per cm pangkat 2, and heavy metals dengan massa jenis 5,308 sampai dengan 22,00 gram per cm pangkat 3. Next. Next view. Specific head. It's the specific head. So the specific head's capacity is the amount of head energy required to rise the temperature of substance per unit mass. Next. Melting and boiling point. The melting point is the temperature at which a substance changes from solid to a liquid, and the boiling point is the temperature at which substance changes from a liquid to a vapor when heat is given. However, metals have high melting and boiling points because metallic bonds are very strong, so it takes a lot of energy to separate atoms metal. Next. Thermal expansion and conductivity. All metals are excellent conductors of heat and electric conduction raised by the movement of electrons. This is because metals have high electrical conductivity, which increases with increasing temperature, and metals also have high thermal conductivity. That's a brief explanation from me. More and less apologize or hopefully this material will benefit you all. Thank you so much.
Thank you, Febri, for the explanation. So next, I'm gonna explain about chemical. Next. First, oxidation. Oxidation reaction are reactions that involve the transfer of electron released by substance undergoing oxidation will accept by substance undergoing reduction. Next is corrosion. The definition of corrosion is the destruction or the deterioration of the quality of the material due to reaction with the environment. The factor occurring corrosion the corrosion of following factor: humidity to unfin metal surface, electromechanical, and corrosion prevention. One is make sure the metal does not come in direct contact with outside air. 2. If the mode in point 1 is difficult, there is another way, namely by using electropainting, which electrochemically coating the metal surface. The metal surface to be contact act as a coat, while the coating it is cause another metal acts as for surface another coated protection, which is a corrosion by preventing the formation of electromechanical cares. Next, flammability. Chemical properties. Flammability is the AC difficult nature of substance to burn. By knowing the nature of combustible material, we can use this material safely. Examples of flammable substances are gasoline and paper. Next. Toxicity. Definition: toxicity can be defined as ability of a toxin to cause the make if enter the body and location of organ that are susceptible to it. Toxin or poison or substance that is malodorous can cause the make to living tissue. What is the main function of toxin? Here can be in form of chemical, physical, and biological substance. Toxicity varies widely various or depending on various factors and such as the test species. The way the patient enter the body, the frequency and duration of exposure, the contraction of and the susceptibility of various species to pollutants. Thanks.
Okay, that's for our presentation. Thank you for your attention. If you have any question, you can write down in the comment section in discussion, or you can ask us directly via Zoom discussion.